So with that setting, you can estimate that the lift force will equals to the buoyant force minus the total weight of helium balloon, including the balloon itself and the helium gas inside. So that will also equals to the mass of air times the gravitational constant minus the mass of helium times the gravitational constant minus 0.04 times the gravitational constant. We put up everything together, we can find out that the lifting power is probably around 130 grams. So to test your overall understanding about buoyancy, here is another question for you to think about. Let's say now I have a helium balloon in hand. What will happen if I let the helium balloon rise? So the answer is, during the ascent, the helium expands because of the fall of air pressure. When the balloons go higher and higher, there are two possibilities. First is, the balloon may eventually burst because the volume continues to expand and the balloon material is not strong enough to hold that pressure. So the other possibility is that it will stop expanding due to the inability of the skin material to stretch further. So the volume stops increasing and the displaced air with the same volume decreases in density as the balloon goes higher and higher. The balloon will reach a ceiling height and stay there when the buoyant force equals to the weight of the whole system. So this balloon will hold on to that ceiling height for a period of time. However, if we also take into account of the leakage of the helium gas, then the balloon will descend gradually with time and eventually come back to ground. Okay, one last question. Imagine that now I have a glass of water with an ice cube floating in it. When the ice melts, what will happen? Will the water level increase, decrease, or remain unchanged? The answer to the question is very simple. It is a test of your basic understanding about the Archimedes principle. So for the situation of this question, if there is no frictional force between the ice cube and the wall of the glass, then the buoyant force equals to the weight of the ice cube. And the buoyant force also equals to the weight of the fluid, which is water displaced. So imagine that when the ice melts, it turns back into water with the same weight, and thus the water level will remain unchanged. Just that simple.